Okay, Assalamualaikum. So for this one, we continue with lecture 4 of topic 9, which is the last topic or last lecture for topic 9. Okay, so last time we stopped at the lecture 3, we're talking about normal distribution. But for this lecture, we are going to continue with the next part of this normal distribution, which is to use the continuity correction in order to solve binomial problems, binomial probability problem, and using normal distribution approximation. Okay, so this continuity correction is a method where we are adapting normal distribution into a binomial probability problems. Okay, why? Because there are certain parts that we cannot solve it by the binomial distribution. Okay, so let's see the concept. So the normal approximation to the binomial distribution. So we have this binomial distribution, but we cannot solve it using the binomial distribution itself. Okay, it's originally a binomial distribution. Okay, it's given the probability of success, it's given the number of trial, but we have these all of this information, but we cannot solve it by using the binomial distribution. Okay, so if x is a binomial with np as the parameter, then mu is the mu is the expected value, which is equal to np. And the sigma square is the variance x, which is equal to npq, where q is equal to 1 minus p. If n is large such that np equal to 5 or more than or equal to 5, and n is more than 50. Okay, so what we have to do, if we have this large n, we have to approximate to normal distribution, where the parameter is the mean and the variance. So the mean is np, the variance is npq. Okay, so from binomial, which is a discrete random variable, we approximate by using the normal distribution, which is a continuous random variable. So from discrete, we change into continuous. So there is some things that we need to do before we use the normal approximation. Okay, now the binomial with the parameter np, n and p will be a normal with parameter np and npq. So this is our normal or normal graph now. So we have mu equal to np and the sigma equal to square root of npq. Okay, the closer p is to 0.4, the better approximation. Means that p is about half. Okay, if it's about half, it's like is about the failure lah, the better approximation. Okay, when using this approximation, remember to use continuity correction. This is necessary because the normal distribution is continuous and it is being used to model the binomial distribution, which is discrete. So we are changing this binomial, not changing, adapting this binomial distribution, which is discrete, into a normal distribution, which is a continuous. So we need to do discontinuity correction. If it's originally a binomial, then we adapting normal, then we have to do this step, continuity correction, before we continue just like a normal distribution, the usual normal distribution. Okay, let's see some example. So probability of x equal to 7. So this is for discrete. Directly we can take from the table, right? Or we can use the formula. But because we cannot, we have to approximate to the normal because the certain condition that we have met, then this value probability of x equal to 7 will becomes probability of x in between 6.5 and 7.5. Okay, why? Because for in continuous random variable, we don't have probability for a certain point. So this 7 here, okay, so this 7, what, sorry, okay, 7 is here, right? So we cannot integrate from 7 to 7, but for the continuous random variable. So what we need to do to include 7, we have to take it before and after 7. So we will have the area on this part lah. Okay, that's why we take the probability from 6.5 to 7.5. We cannot take from 6 because this 6 will be included. And we also cannot take up to 8 because 8 will be included. Before 7 and half after 7. And we write this probability of x equal to 7 will be probability of 6.5 is less than x less than 7.5. And then this is in binomial distribution. Okay, after we do the continuity correction, this will be in the normal distribution. So after we get representation in normal distribution, what we need to do? Yes, we follow through the step as we do for the normal distribution, which is to standardize. Okay, so let's see, this is our graph, right? So 7 here, we need to include all the value on 7. So we have to take before 7, which is 6.5 up to 7.5. Okay, so how about this? X is at least 7. So x at least 7 is equivalent to x more than or equal to 7, right? We rewrite it as probability of x more than equal to 7. So we have 7. Okay, 7 and above. Okay, what we need to do to make sure that 7 is included in the table? Okay, because it's from discrete, so we need to make sure 7 included. We have to take before 7. Okay, so before 7, for this continuity correction, what we need to take is we hug it from the outside because we need to make sure 7 is included. So we need to take from, yes, the left side of 7 is 6.5. So from x more than or equal to 7, it will be, the continuity correction will be probability of x more than 6.5. So we take from 6.5 and above. Okay, to make sure that 7 is included. Okay, so this is our binomials, 6.5 and 7. To make sure 7 included, we take from 6.5. Okay, so now for C, probability of x is more than 7. So we rewrite it as x more than 7, greater than 7, more than equal, more than only. We don't have equal sign. So if we want more than 7, means that 7 is not included. So we have to make sure 7 is not included. So we use we cut the line. Why? Because we have to make sure 7 is not included. We take a bit more than 7, which is 7.5. That's why probability of x more than 7, after the continuity correction, it will be probability of x more than 7.5. To ensure that the 7 value is not included in the probability. Okay, so because 7 is not included, so we take from more than 7.5. Okay, so now for D, probability of x is 7 or fewer. Okay, 7 or fewer, or we write down as probability of x less than or equal to 7. So this 7 must be included and before. So must be included, so we include them. So we hug them. Okay, that's why we take from, a bit more than 7, which is 7.5, not 8.5, sorry. It's 7.5. Okay, so we take from 7.5 and before. So it will be from probability of x less than or equal to 7. After the continuity correction, it will be probability of x less than 7.5. And lastly, for probability of x is less than 7. So 7 here is not included. So we have to make sure 7 not included. We cut the ties. Okay, we cut the ties. So where is this ties? So it's 6.5 a bit before 7, which is 6.5. So probability of x less than 7. After the continuity correction, it will be probability of x less than 6.5. Okay. So this is our binomial distribution. Okay, we don't want 7. Make sure the 7 is not included. So we take a before 7, which is 6.5. Okay, now also note that. Why? Sorry, it's going above. Sorry, let me check. Where is the? We stop here. Also not that. Okay. Also note that probability of x in between from 3 to 5. Okay, so let's see on the number line. 3 to 5. So we want to include 3 up to 5, right? So we have to include both values. So what we need to do is to hug them from outside. So it will be here is 2.5 and a bit more than 5, which is 5.5. So after the continuity correction, it will be probability of x from 2.5 to 5.5. For probability of x less than or equal to 3, in between 3 and 5 not 3 included. So 3, 5, so 3 included but not 5. So we hug the 3 because we want to include, but for 5 we need to cut the ties. So cut the ties means that we take from 2.5, here is 2.5, and here before 5, which is 4.5. That's why probability 3 less than or equal to x less than 5 after the continuity correction will be probability of x in between 2.5 and 4.5. And then probability of x, so now here is 3 is not included but 5 is included. Okay, so 3 is not included, so we have to cut the ties. 5 is included, now we have to hug from outside. Okay, so cut the ties, here will be 3.5, here will be 5.5. So that's why probability of 3 less than x less than or equal to 5 after the continuity correction will be probability of x in between 3.5 and 5.5. And lastly, for 3 and 5 both are not included. So if not included means what? We have to cut the ties. Cut the ties on both parts. So it will be 3.5 here and here is 4.5. So probability of x in between 3.5 after the continuity correction, it will be probability of x in between 3.5 and 4.5. Okay, we have to do the continuity correction even though we don't have equal sign. Everything we need to do continuity correction. No exception. Okay, so let's say example. If x is a binomial with 100 and 0.25 as the parameter, find the probability and dot, 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 dot. Okay, now we can see that our n here is equal to 100, which is more than 50. And p is equal to 100 multiplied by 0.25, which is equal to 25, which is more than 5. So this characteristic indicates that we have to do the normal approximation. Okay, so what is the normal approximation? So x is a binomial with 100 and 0.25. After the approximation, x will be the normal with 25 as the NP and 18.75 as NPQ. So multiply, this one is 100 multiplied by 0.25. This one is 100 multiplied by 0.25 multiplied by 0.75, which is the Q. Okay, now we have the normal distribution already. Now to find the probability, we need to do first step. For probability of x equal to 27, for discrete is okay. We can use formula, but because we have done the approximation, we need to use the normal. Okay, because this is more than 50, we have to use the normal distribution. So to do the normal distribution, first of all, before you standardize, what you need to do is to do the continuity correction. Okay, the continuity correction, if it's equal, then we have to take. So you can draw 27. We want 27 only, so we hug it from outside. So we need to take from 26.5 up to 27.5. That's why after the continuity correction, it will be probability of x in between 26.5 and 27.5. And then after that, we continue as usual, which is the from normal distribution. So this is from binomial. This is to normal. And then we use the standardized. We need to standardizing. So this will be standard normal distribution. Okay, from binomial to normal, normal to standard deviation, standard normal. Okay, so all of this step will be following lah. You cannot skip. From binomial, we need to change to normal. After that, as usual, to solve normal, we need to use the standard normal distribution. So this is continuity correction. Second step is standardizing. Okay, Now we can have the value of z lah, which is z is between 0.35 to 0.58. And then to solve for this one, both on the right side of 0. So after we sketch the graph, we can see that both on the right side of 0. So if both on the right side of 0, we need to take the bigger triangle to subtract the smaller triangle here. So the bigger triangle is probability of z more than 0.35 minus probability of z more than 0.58. So we have the value from the table. We substitute the value and subtract it, and then we have the answer, which is equal to 0.0822. Okay, so this is for question A. For question B, we want to find probability for x more than or equal to 28. Okay, now, before we continue with the standard normal distribution, first of all, we need to use this continuity correction. So from probability of x more than or equal to 28, it's the discrete random variable 28 is included. To make sure that 28 is included, we hug it from the outside. Okay, so we have to take from 27.5 and above. So it will be probability of x more than 27.5. And then after that, we can standardize. So this is a continuity correction step. The second step is standardizing steps. So standardizing step, it will be 27.5 minus the mu, which is 25, divided by sigma, which is square root of 18.75, which is equal to probability of z more than 0.58. So 0.58 is on the right side of 0.58 on the right side of 0. So we want probability on the right side of 0.58. So directly we take from the table because it's small triangle, which is equal to 0.2810 lah. And then for question C, probability of x more than 18. So this 18, to do the configuration, is 18 is included? No. So if not, then we have to cut the ties. So this is the tie, we cut it. So what we need to do is to take from 18.5 and above. So it will be, oops, oh Allah, sorry, tekan N. Sampai mana tadi? No. Oh no, okay, sorry. No, not this question. I go ya, sorry ya. Mana tadi? 28. Here. 18 is not included. So we have to cut the ties. So we take from 18.5 and above. Okay, so 18.5 and above. So step continuity correction done. And then we continue with standardizing, which is use the formula x minus mu over sigma, which is 18.5 minus 25 over square root of 18.75. So what do we get for the value here? It will be a negative value. So negative value from the table, negative 1.5 will be on the left side of 0. So we want the area that bigger than it. So what we need to do to subtract the smaller triangle. We always subtract smaller triangle or take we have the value of smaller triangle from the table. So here is actually z less than 1.5. So 1 minus z less than 1.5. This is z less than negative 1.5. Sorry, z less than negative 1.5 is equivalent to, if we take the triangle, it will be, the one we want is less than 1.5, or we take out the z more than 1.5. So that's why 1 minus probability of z more than 1.5 from the table, 1 minus 0.0668, which is equal to 0.9332. Okay, so for question D, probability of x less than or equal to 20. So 20 is included or not? Yes, 20 is included. So we have to hug it from the outside. Peluk dia dari luar. Sebab dia termasuk, so dia keluarga kita. So kita peluk dia. Okay, so means that we have to take, yes, not 20 but 20.5 and before. So probability of x is less than 20.5 after the continuity correction. So the next step is to standardizing, use the formula. Probability of z is less than 20.5 minus 25 divided by square root of 18.75. So we get probability of z less than negative 1.04. So on the table, on the graph, negative 1.04 is on the left side of 0, which is the area less than will be this area, the smaller triangle. So we can directly reflect it to the right side, which is equivalent to more than 104, more than 104. The Z is more than 1.04, which is we can directly take from the table, which is equal to probability equal to 0.1492. Right? Okay. So we are done with the question directly from the we have a direct question lah. So we continue with the next example. We have question E sorry. Pula madam ni. Okay, so for question E. Okay, so we have X is a binomial with 100 and 0.25 as the parameter. The same thing lah, but we want to find probability of X from 20 to 35. 35 is not included. So on the number line, 20 to 35. 20 include, 35 is not. So for 20, we need to hug it. Peluk dia dari luar sebab dia termasuk dia keluarga kita. 35 is not included, so dia tak termasuk, kita putuskan hubungan. Cut the ties. Okay, so what we need to do is to take from, yes, before 20 is 19.5 up to before 35, which is 34.5. Okay, so after the continuity correction, it will be probability of 19.5 less than X less than 34.5. So after that, we can continue with the standardizing lah. So standardizing, we have probability of 19.5 minus 25 over square root of 18.75 is less than Z and less than 34.5 minus 25 divided by square root of 18.75, which is calculated, we get the value of Z in between negative 1.27 and 2.19. So on the graph, so negative 1.27 is on the left side of 0 and 2.19 is on the right side of 0. So we want the middle part. So the middle part, usually we take out the smaller triangle, which is the first smaller triangle is Z more than 2.19. Okay, this is Z more than 2.19. And then this area is Z less than negative 1.27, which is also can be written as Z more than positive 1.27. Okay, so 1 minus probability of Z more than 2.19 minus probability of Z more than 1.27, which is from the table, we have the value 1 minus 0.0143 minus 0.1020. So we have the value, calculate the final answer will be 0.8837. Okay, as usual, because it's a binomial, originally we do the approximation. The first step we need to do is continuity correction. After that, baru kita standardize dia. Okay, now, example 2. So this is a real life situation or problem solving situation. In a box containing 100 apples, the probability of picking a rotten apple is 0.2. Find the probability of picking at random 5 rotten apple and 5 to 6 rotten apple. Okay, now we have this situation is talking about number of apples, right? So number of apple, we don't have 1.5 apple, 2.5 apple, tak ada. Tapi disebabkan N kita, this is a binomial distribution lah, because it's talking about probability of success picking a rotten apple. So we have number of sample, which is 100 apples, which is the N, and we have the probability of success talking about picking a rotten apple. Okay, so we can describe that this X is talking about number of rotten apple. So the number of apple is 100. The probability of getting rotten apple is 0.2. So it's a following binomial distribution. So you have to do this step. Following this step, X is a binomial with 100 and 0.2 as a parameter. Okay, because we have X more than 50 and NP is equal to 2, which NP is equal to 20, which is more than 5, then we have to do the approximation to normal. So approximation to normal, we need to find what is the mean and sigma square lah. So mean, mu is equal to 100 multiplied by 0.2, which is equal to 20. Sigma square is equal to 100 multiplied by 0.2 multiplied by 0.8, which is equal to 16. That's why X is a normal with 20 and 16 as the parameter. Okay, so now we can continue with solving the question lah. So what are the question? First, the question is talking about Do we need to show, sorry. First of all, do we need to show how do we find the mean and sigma square? So we can show mu is equal to 100 multiplied by 0.2 equal to 20. Sigma square equal to 100 multiplied by 0.2 multiplied by 0.8, which is equal to 16. But if you didn't write x is normal with this value, then you cannot have the marks. So make sure you write down this part, x is normal, after the continuity correction. Okay, so now to find the first question, they ask you to find the probability that at least equal to 5 apple is rotten. Okay, we find out the 5 apple is rotten. So 5 for binomial, we can directly find it by using formula, right? But because we we do the approximation, we have to apply the normal. For the normal part, for equal to 5, we don't have it. So for 5, we need to take out from before 5 and up to after a bit 5. So it will be before 5 is 4.5 up to 5.5. So this is the continuity correction step. And then after that, we have from binomial to normal. Nominal, we have to change from normal to the standard normal distribution. So do the standardizing, use the formula. So it will be 4.5 minus 20 over square root of 16 less than z less than 5.5 minus 20 over square root of 16, which is equal to z in between negative 3.88 and negative 3.63. So on the graph, both on the left side of 0, right? So how do we find it? Okay, we cannot take the table, the value in table with a negative number. So what we do is to reflect it. So reflect this 3.63 and 3.88. It will be this negative 3.88 and negative 3.63 will be positive value. So we have both on the right side. We need to use the triangle. The bigger triangle minus the smaller triangle. So probability of z more than 3.63 minus probability of z more than 3.88. Okay, make sure that we have the bigger triangle minus the smaller triangle. Usually, if you confuse, you can check. If you get the answer negative, then it's wrong lah. Because probability cannot be negative. So what is probability of z more than 3.63 on the table and 3.88 on the table? We have 0.00014 minus 0.00005, which is equal to 0.00009. Okay, so this is our answer from the table. We take from the table, right? Okay, so for question B, probability of x is from 5 to 6. So, from 5 to 6. So, we interpret it from 5 to 6. So, let's check the question again. Find the probability of picking at random 5 to 6 rotten apples. So, both are included lah, right? So, from 5 to 6, do the continuity correction. We have to make sure 5 and 6 is included. So this is 5, this is 6, both are included. So we hug it. Kita peluk dia dari luar. So we have to take before 5 and after 6. So before 5 is 4.5, after 6 is 6.6. So after do the continuity correction, it will be probability of x in between 4.5 and 6.5. So after that, we do the standardizing. This is the standardizing method. So use the formula 4.5 minus 20 divided by square root of 16. 2z to 6.5 minus 20 over square root of 16. So use the calculator, we get the answer negative 3.88 less than z less than negative 3.38. Okay, so both on the left side, so we cannot find from the table. So we do reflection. So both will be positive on the right side. So we take the bigger triangle, which is the triangle for 3.38 minus the smaller triangle for the 3.88. So probability of z more than 3.38 minus probability of z more than 3.88. So the value will be 0.00036 minus 0.00005, which is equal to 0.0031. Okay, so this is the answer for the example 2. So now we continue with the last example. Okay, wow. Okay, this example usually will come out in exam. So we have these more examples like this in the miscellaneous tutorial question, miscellaneous question. So we can apply what we learned here. So a large box contains many plastic syringes The previous experience indicated that 10% of the shrink in the box are defective. So it's talking about 10% defective shrink. Okay, so 5 shrinks are taken at random from the box. Find the probability. Okay, 5 shrink. So 5 shrink is talking about the number of shrink. So number of defective shrink is the X lah. So we can explain, we can define that we use X as the number of defective shrink with the number of shrink n is equal to 5. So here n equal to 5 and probability of success for defective shrink is equal to 0.1. Okay, so we have 5 shrink are taken at random from the box. Find the probability none of the 5 shrink is defective. So none means that X equal to 0. And then at least 2 shrink out of 5 are defective. So at least 2 shrink. At least is more than or equal to 2. So we have defined what we want to find. So it's following a binomial distribution. Okay, but now for question B, instead of removing 5 shrink, 100 shrink are picked at random and removed. So now we have n equal to 100. Okay, for question B means that we have to use the estimation or approximation of normal distribution. Okay, now let's do question A first. So X is the number of defective shrinks. So probability number of trial or number of sample is 5 and probability of defective shrink is 0.1 or 10%. So we have X following a binomial with 5 and 0.1 as the parameter. Now to find probability that none of the shrink are defective, so it's equivalent to probability of X equal to 0. So because it's binomial and it's smaller than 50, we can use the formula as usual lah. So it will be 5C0 multiplied by 0.1 to the power of 0 multiplied by 0.9 to the power of 5, which is the answer is equal to 0.5905. And then for the question is at least 2, right? So probability of X more than or equal to 2, we can directly pick it from the table. So we have n in the table. We have also p in the table. So let us check together. In the table, more than 2. Show taskbar. So we have the table for n equal to 5, p equal to 0.1. N equal to 5 will be, where is n equal to 5? Alah, sorry terkeluar. N equal to 5. N equal to 5, P equal to 0.1. Here, page 5. N equal to 5. N equal to 5, P equal to 0.1 for X more than 2. More than equal to 2 is equal to 0.0815. You can see here, it will be 0.0815. The answer is. So we have directly the answer from the table 0.0815. So we're done with question A. How about question B? Okay, so for question B, because we have 100 shrink, the number of shrinks are 100. This 100 is more than 50. So we check NP, we get equal to 10. So more than 5. So what we need to do? We need to do continuity correction. Okay, so let me padam. Sebenarnya tak ada, ni ada pula. Okay, so we can do the continuity correction because n is more than 50 and p is more than 5. Therefore, it is suitable to use normal distribution to approximate the binomial distribution. So, what we want to find? Let us read the question again because we interpret just earlier. Okay. A normal distribution may be used to estimate probability that at least 15 out of 100 shrink are defective. Okay, give a reason why it may be convenient to use a normal distribution to do this and calculate the required estimate. Okay, now they ask you to find the at least 15. So, probability of X more than, therefore, this is the reason. Therefore, normal distribution to approximate the binomial is suitable to use. So, we're answering the reason. Now, to find the probability. To find the probability, we have a binomial, we do the continuity correction, we have to find the NP and NPQ or the mean or the sigma square. So NP is equal to 10, NPQ So mu is equal to NP, which is equal to 100 multiplied by 0.1, which is equal to 10. And sigma square is NPQ, which is equal to 100 multiplied by 0.1 multiplied by 0.9, which is equal to 9. So we have the parameter of normal is 10 and 9. Okay, now to find the probability of x more than or equal to 15. Okay, so let me erase erase the ink first. So we want to find probability of x more than equal to 15 because we do the continuity correction. 50 is included, 15 is included. So to make sure 15 included, we hug it from outside. Peluk dia dari luar. So we need to take from before, a bit before 15, which is 14.5. So this is the step of continuity correction. And then after that, what we do? Yes, we standardize because we have normal already. Now we have the standard normal, which is 14.5 minus 10 over square root of 9, which is equal to 4.5 over 3, which is equal to 1.5. Okay, so 1.5, probability of Z more than 1.5, we can directly check from the table, which is from the table. Let us check together. Screen, show task. Apa ni? Sorry. Kita nak check daripada table. Bukan nak tunjuk skrin putih. Okay. Normal last kali 21. So 1.5. So 1.5 it will be 1.50 lah, which is 0.0668. Okay, betul ke? 0.068. Yay, betul. Okay, so kita check the table. So we get the answer. So, we finish lah. That's all. We just have to do the continuity correction and then standardize as usual. That's all for this type of question lah. So make sure you know what is the reason you do this. So make sure it's really n more than 50 and np more than 5, then we can do the continuity correction or normal approximation. Okay, so that's all for 9.3. So we finish with topic 9. Okay, so for normal, we have two parts. The first one, to find the probability as usual, to identify and so on. And the second part is the normal approximation from binomial distribution. Okay, so finish already for topic 9. Thank you. And you can try to do the question, tutorial question. And of course, the miscellaneous question, the exam question. Okay, thank you. Thank you, guys. Please go out. Okay, so we finished the broadcast. And the broadcast.